When taking derivatives, we often rely on a list of rules: power rule, quotient rule, product rule, chain rule, etc. Finding antiderivatives is a little bit more sophisticated, and while rules can be formulated and can be helpful, it's often helpful, if not required, to think about your work as you go when you're finding antiderivatives and check your work as you go. For instance, to find the most general antiderivative of the given function, f of x is x to the 1/3, we could rely on a rule that says that the antiderivative is x to the 1/3 plus 1, add 1 to the power, divide by the new power, and add an arbitrary constant. And that we could simplify, and that is indeed the correct answer. However, I want to show a way of thinking about this step by step. We want to find a function, big F of x, so that when we differentiate it, we get exactly little f of x, which is x to the 1/3. Well, little f is a power function, x to the 1/3. When you differentiate power functions, you wind up reducing the exponent by 1. So if we want to antidifferentiate, we should increase the exponent by 1. So let's just start by taking x to the 1/3, and we're going to add 1 to it. That will form part of our expression for big F of x. And I'm going to leave it like that for now, but I am going to simplify the exponent. So 1/3 plus 1 is 4/3. Now, if we leave it like that, x to the 4/3, if we differentiate that by the power rule, we will obtain the 4/3 comes down in front, x to the 4/3 minus 1. This is 4/3 x to the 1/3. Now, that's in some sense close to the function little f of x, but this factor of 4/3, we don't want that there. So what we'll do is we'll take our original big F of x up here, and we will divide it by 4/3. We'll divide by 4/3 over here. Now, when we take the derivative, that denominator of 4/3, because it's a constant, it will just remain there, and so we'll see that this 4/3 in the numerator will cancel with the 4/3 in the denominator, and we'll be left with x to the 1/3. And so we've succeeded in finding an antiderivative for the given function, namely x to the 4/3 divided by 4/3 is an antiderivative of this function little f. Let's just take a moment and simplify this. If I have 4/3 in the denominator, I can write that as 3/4 times x to the 4/3. However, there's one more little thing, well, not a little thing, it's important, the most general antiderivative. Now, there are other functions, big F of x, whose derivative is x to the 1/3. In particular, if I added a plus 1 here, and I'll add it all the way across, if I take the derivative of that, the derivative of a constant is just 0, so I would have plus 0, plus 0, plus 0. In fact, that 1 could be anything at all. So I will add an arbitrary constant c, and this right here is the most general antiderivative.